Hey you guys, I'm going to do a quick summary of all things dilations. I've had a few questions and I'm hoping that this might help you out. So remember there are the 2 Zoom meetings, or actually 3 now, for the last couple days, and you can also look at Math Nation, but I kind of want to put some things, like I said, just down as a summary. The first thing is that when you're doing a dilation, is it about the origin? If it's about the origin, all you have to do is take your x, y value of your a prime, whatever, and just multiply it by the scale factor. So multiply the x value, multiply the y value, you have your new coordinates. All right, is the dilation centered at a point instead? Well, if it's centered at a point instead, that's where it gets a little hairy. So I'm going to write down the basics first, and then we're going to do a problem. So the first thing that you want to do is, I'm going to write that as your center or point of dilation. I say both, it really doesn't matter. Okay, so the first thing that you're going to do is you're going to look for your horizontal change. And that should remind you of your run, okay, when it comes to slope. So x2 minus x1, where the center of dilation is your x1, y1. You do the same thing for vertical change. So think of it as your run, your rise. y2 minus y1. Once you have those two changes, then, so let's do it this way. Once you have your two changes, the next thing that you're going to do is you're going to multiply your changes by the scale factor. After you multiply those, then you will add them back to x1, y1 to get your new dilated point. There's also a little formula that you can use if you choose to do so. You would have your dilation about a point. I'm going to use x comma y. And what you're going to do is you're going to take your initial x, you're going to add the scale factor times the run. And know that the run is x2 minus x1. And it has to be in that order. You can't flip-flop it. So again, this is just another word for run. That will give you your new x coordinate. For y, you would take your y1 plus your k times y2 minus y1, also known as your rise. And that will give you the new coordinate. All right, so let's take a look. We're going to do it both ways, and then we're going to use that formula. So I'm going to kind of leave the formula up here. So for instance, I have a center of dilation at -3, 1. My scale factor is 2. The point that I'm dilating away from -3, 1, I'm going to call A, and that's at -4, -5. Let's go ahead and throw another point in there so we can make AB a line segment instead of just dilating a point. So I'm going to make that 1, 7. All right, so this is what we've been doing the last several days in class. We've been taking -3, 1. That's our center of dilation. That's our x1, y1. Okay, I am finding my horizontal distance and my vertical distance, but first let me write down my coordinate of each. Okay, so in order to find the horizontal, that is going to be taking my x2 minus x1, so -4 minus a -3 actually gives me a -1. So remember, -4 minus a -3 gives me -1. Find my vertical change. -5 minus 1 gives me a -6. Horizontal change for B. Now this becomes our x2. 1 minus a -3 actually gives us a +4. It's going 4 units to the right. Our vertical change would be y2 minus y1, so 7 minus 1 will give us 6. We're going to multiply all that by the scale factor of 2. And I get -2, -12, 8, 12. Okay, the last step that it says up there is to add it back to our center of dilation. So -3, 1. I'm going to put it down here as well, -3, 1. I'm going to subtract 12, subtract 2, subtract 12, add 8, add 12. And let's see what our new points will be. I'm going to change color to make it a little more exciting. So -3 and a -2 give me a -5. 1 minus 12 gives me a -11. So my new coordinate for A prime is at -5, -11. My new coordinate for B prime, -3 plus 8 is a +5. And 1 plus 12 is 13. So my new coordinate is going to be at 5, 13. Now, all that is great. Hopefully that made sense. If you want to use this formula instead, I'm going to write the formula down again. I'm actually going to give myself a new page. Okay, so that formula was basically x1 plus k times the run. And we know that the run is x2 minus x1. And the other one would be y, don't know why it's doing that, y1 plus k times the rise. And we know that the rise is y2 minus y1. Okie doke. Our starting point was, I'm just going to do A prime, -3, 1. Okay, so this is x1, this is y1. So I'm going to put -3 plus the scale factor of 2. Over here, 1 plus the scale factor of 2. Okay, I'm going to go back up here. I don't want to do the whole thing over again. We found that x2 minus x1 was a -1. So my run was -1. Oops, and y2 minus y1 was a -6. So -1, -6. Let me remember that. So the run was -1. The rise was -6. So let's see if this formula works. 2 times -1 is a -2. And -3 plus a -2 is a -5. Okay, over here, 2 times a -3 is a -12. Plus 1 is a -11. Was that our coordinate for A prime? -5, -11. Yes, it was. Okay, so I hope that helped. This formula right here is just one more thing to remember. But the way that we did everything over here with the horizontal and the vertical change is the same thing that we're doing here. Okay, so let me know if that's helpful. Again, it would be something you would have to memorize for the EO.